Welcome to our webinar today called Bring Your Buried Assets to Life. My name is Bill Meehan. I'm with Esri. This webinar was brought to you by EOS, Esri, and OHM. It's also a story of digital transformation at Oakland County, Michigan, particularly in regards to their buried assets. You know, when I think of digital transformation, there are really two things. The first is certainly digital technology and modern digital technology, but also it's about, it's seeing things in a new way. It's about a change of behavior, and we're going to see that today. It's about process differences, doing things just differently, seeing things differently. But when I think about digital transformation, I think that sometimes people misunderstand that. They sometimes say, well, if I just digitize something or I computerize something, it's going to be okay. A lot of people just scan their paper maps and scan their records, but they don't really oftentimes use it in a new way. They don't think of things in a new way. That's really called digital transition. But we're going to talk about digital transformation today because it's really about taking a whole new approach to kind of an age-old problem of finding something underground. Well, when I think about finding something underground, I'm brought to mind a situation that I should have known better. So I grew up in the city and I moved to the country and I had this beautiful lawn. But what I had was a buried septic system, a buried septic tank. So what I discovered was that every 2 to 3 years, you had to pump it out. So I called a contractor and said, okay, pump out my septic system. And he said, well, you have to think about this because you have to expose the cover of the septic system. We're not going to do it. So I'm like, well, I don't really know where it is. So I had to kind of dig holes, and I dug about 10 holes. Finally, I found the cover, banging, found the cover, dug the hole. It's about a 12-inch hole. And then, had it pumped out and everything was fine. So I backfilled the hole and put the grass back. I carefully reinserted the grass sections, and I had this beautiful little 12-inch circle. Now, what I should have done, and I should have known better, I'm an engineer after all, I should have measured the hole and taken measurement from the house and maybe drew up a sketch. But it was, it was getting late and I had dug all these holes and I'm like, okay, I'm done with this whole thing. Well, 3 years later, I go to have the septic system pumped out again, and my beautiful lawn had grown over, so you couldn't even have, and there was no evidence of where I had dug the original hole. So I had to dig more holes, and I did it. But this year I was going to be smarter. So I did. I measured, I created a sketch, but then 3 years after that, do you think I could find the sketch? No, I couldn't even find the sketch. So I was back in the same situation I was all over again. Well, I worked for the power company for a couple of decades, and we had a similar situation with underground assets. Many years ago, contractors had installed what we call direct buried cables. They weren't in conduit; they were just directly buried, and they would dig a trench and put the cables in them. And the problem was the contractors were not particularly diligent about where they documented where they had buried the cable. Nobody cared until, of course, 30 years later, we had a rash of failures on the direct buried cable. So we'd have to go out there, and we didn't have any really good records of where the cables were. So we had to take backhoes and dig up the people's front yards and the streets because they were all over the place. And then when we found them, you would think, after we discovered where the cables were, we would be very diligent in documenting exactly where those cables were located. Well, we didn't do that. And if we had done it on the sketch, who knows where the sketch was? We probably lost it. So finding buried assets and locating buried assets is an age-old problem. And my colleague, Pat Hole, also works for Esri. He's going to talk a little bit about his experience. He worked for a power company as well. So I'm going to turn it over to Pat. Tell us your story, Pat.
Well, thanks, Bill. I bet we all have a few stories like that, and please don't even get me started on direct buried cable. I do remember I was on call one weekend, and there was an underground outage that included a large apartment complex, and we had a lot of customers out of power for a long time. And it was taking the crew a very long time to locate the problem. The crew reported that they were unable to find the 3x5 primary pull box where they were to start their work. Now, this was an older installation. It was in a planter, and Ivy had grown up over the years all over it. And they knew approximately where it should be, but they were probing with digging bars and shovels, sounding for the hard lid in the ivy, and they couldn't find it anywhere. I eventually went to the office and pulled the original construction as built. And using that, I gave them a measurement from the retaining wall, and they were able to find the box. But we wasted hours just trying to find the equipment. Now, once we found it, we got to work, we made repairs and restored service. But it was aggravating, and it took far longer than it should have taken. Over the years, I was really surprised to learn that most underground crews carry divining rods, kind of a last resort for locating underground facilities. I've seen crews pull them out, and some are sticks, some were made from scraps of copper wire, and you hold them lightly, one in each hand, and the theory is that they cross over each other when you're over a buried object, kind of like a utility Ouija board. Now, I've seen them used, often fail, and occasionally work. But I would hate to rely on that when customers are out of power and when that outage is trending on Facebook. Far better to capture the exact location in 3 dimensions, store it in GIS, and then use that information forevermore. And that's exactly what we're going to look at today. Okay, enough stories. I'm Pat Hall from Esri, and thank you all for joining us. Today's topic is a deep dive into real-world experiences in Oakland County, Michigan, and I'm joined by a magnificent lineup of speakers. With me are Jason Warner from Oakland County, Michigan, Michael Cousins from OHM Advisors, my colleague Bill Meehan, you already met, and Jean-Yves Latour from EOS Positioning Systems. Thank you all for sharing your time and your expertise with us. Please ask questions throughout the webinar. We will save time for your questions near the end, so type in your questions as we go along, and as usual, this is being recorded, and please use the logistics panel to adjust your view as needed throughout the webinar. Here's our agenda. I'm going to start with a short 1-minute video to give you a quick look at the state-of-the-art locating technology in action. I think that seeing it is so valuable. Mike and Jason, they face some real issues with underground facilities, and I think they're things that we can all relate to. After the video, they will take us through those challenges and how they address the problems, the kind of business results that they achieved, and then I'll highlight some key takeaways, and we will definitely save time for your questions. You might be wondering, how do we bring buried assets to life? Let's look at a high accuracy mapping in action, and let's roll the video now. I love seeing the different ways that the equipment is actually used, and even the potential for 3D and augmented reality. Those are the kind of applications that are becoming much more important to help orient, I think, particularly newer employees that expect things to work that way for things like training and job design and safety. Jason, welcome to the webinar and thank you for taking the time to tell us your story. Could you start us off by orienting us to Oakland County and your responsibilities there?
Yeah, thanks, Pat. I'm happy to be here today. Oakland County is about 30 miles northwest of Detroit. The Oakland County Service Center consists of more than 600 acres of land and houses over 40 county buildings. The Facilities Planning and Engineering Division is one of two divisions in the Facilities Management Department. We're responsible for project management of major construction and renovation projects for the county buildings. Additionally, we provide technical support for county facilities, which includes maintenance and building record documents. And we also maintain all of the underground and above ground utility and infrastructure data and plans. Our story here at the county starts with an old oak tree.
So we set off on a journey with the county last year to update their GIS infrastructure. Here's where we started. In this image, you will see the yellow dashed line being the record plan and GIS polylines. The pink line would have been what we would have had to collect had we just walked the site to find the connection points. Very schematic looking. And obviously we knew that both sets of data were incorrect. The connection point to the west was about 70 feet off. The connection point on the east was on the wrong side of the building. But when you turn on the aerial, you can see this giant old oak tree right in the middle. Obviously inaccurate. There are many examples across the campus where the utilities were just flat out incorrect like this. We knew the data was inaccurate. Their field staff knew the data was inaccurate. We had to do something to make it better.
At the county, my group is responsible for 9 systems: water, sewer, storm, gas, electric, steam, and telecom. Telecom includes copper, fiber, and CCTV. As Mike mentioned, there was a lack of trust in our existing GIS system. It was built from old as-built and not very accurate CAD drawings. Most of the existing data was derived from AutoCAD drawings that was scaled from old Mylar prints. No geolocations were captured up until this point. At the county, we have a custom asset management software solution with CityWorks. When we receive a work order, they can be tied spatially. So when the GIS was not up to date, it led to frustrations in finding and tagging the appropriate assets. There was a lack of trust in the maps being used, and this caused for lack of maintenance and reporting of work orders. As new projects were planned and the design phases were kicking off, our engineers and architects would go to the existing campus utility plan as a base to start. But like we saw in the previous slide, we had to take it all with a grain of salt. Oftentimes we designed something in a particular corridor, then as construction started, we would quickly realize that we could not put the utility in the intended location due to inaccurate records. We have encountered several underground utility strikes when digging because the drawings weren't updated. Each time there was a shutdown of work, it added costs and time per project. This caused our crews to spend a lot of time hand digging to locate assets. This dramatically impacted our building users. When there was an emergency response and we need to locate valves to turn them off in the wintertime, it would take a lot of time to locate valves in the snow based on existing locations using our old data. When we went to misdig our assets on campus, we would measure off a location and use standard utility locators if possible. This all took additional time as well.
So for those that don't know, MISDIG is the 811 program for Michigan, and it's their call before you dig program. It's a one-call notification system that was developed in order to provide excavators and the general public the ability to inform multiple owners of underground facilities of excavation with a single call. In the AEC world, job shutdowns and utility strikes are a bad day for all parties involved, both financially and mentally. Most companies will send out a utility locate company and mark or flag out the ground of those buried assets. That's your first set of eyes. Then we'd send a surveyor out to survey those same assets, your second set of eyes. Then it would get handed over to the CAD group to convert the CSV files from the survey collectors to create features, again, your third set of eyes. And then maybe, a big maybe, it gets back to us in the GIS world to update those same assets, your fourth set of eyes for the same structures. But it usually doesn't get to us at the fourth step for us GIS professionals to update the data. These potential 4 sets of eyes on the same asset equates to a lot of time spent, which is also a lot of money. What if there was a better way?
Long story short, We had to find a better solution to update our data once and for all and build trust back with our staff and our field crews.
Well, those challenges were really, really difficult. So what did you do? What was the solution? So Jason and Mike, tell us a little bit about what you actually built. What was the project like?
So Oakland County approached OHM advisors to assist the county in updating their data. As a regional GIS expert and a partner with the county on a few other initiatives, we got together to figure out how to solve this problem once and for all. Our overall goal was for high accuracy and, most importantly, high confidence in our GIS, which is ultimately the backbone of everything that they do.
But the question became, where do we start? How could we be cost effective in updating our data? Besides GIS and our plans, were there other ways that we could collect our data?
So in order to estimate appropriate budgets to capture the whole campus, which is fairly large, we decided to do a small pilot AOI to see how long it would actually take. Initially, we were planning 4 weeks to walk the pilot area using traditional methods of locating, our eyes, metal detectors, probes, and even our trusty witching sticks. We were going to try to use the existing GIS and plans to walk the area as a reference and try to locate these assets.
Once we got the project underway, we knew that 4 weeks might be a little bit generous. Back to the old oak tree. That was one of the first areas where we started. We got on site and attempted to find the gas main and realized it wasn't that accurate. So back to the drawing board we went.
With all technology, both hardware and software, I love to follow what the great Bruce Lee is famous for saying, and that's be water. So in working with EOS over the years, we had learned about a new solution that they had recently deployed in the last year, and that was EOS Locate. And we explored it further. You have to keep your eyes open to new solutions, both hardware and software, that come out every year. We acquired the necessary equipment, which I'll explain here shortly. We went back to that trusty oak tree, set up on it, and within minutes, we had centimeter level accuracy, both horizontal and vertical, of that same gas main. This was our aha moment. So using EOS Locate in conjunction with ArcGIS field maps, it was the perfect data capture solution for us. We utilized a 5X VLOC 3 Pro utility locator device paired to an iPhone or iPad that was running field maps. What we liked about the solution is that we were able to get trained on it very easily from both the software and the hardware side. Also, it was very fast, but most importantly, it was very accurate. We knew that the key to success, though, was data preparation and the creation of a solid collection map. Using field maps, we set up minimum accuracy thresholds to ensure that we were capturing accurate locations. We used multi-point averaging and set a limit where we could not capture a point unless it met our requirements. We also utilized a laser for spatial offsets where we couldn't acquire the designated accuracy requirements for the project. But when we dove into the data, we realized that it wasn't standardized and it lacked a lot of consistency across the various features in each of the 9 utility data sets. Again, gas, power, water, sewer, storm, telecom, which is copper, fiber, CCTV, and also the steam tunnels. So OHM advisors reached out to Bill and his team to inquire about the various utility network solutions in which they have either developed or were in development. This was key because not all of the systems we were trying to capture had a utility network framework published yet. Working with Esri, OHM in Oakland County found the appropriate solutions that met our need, and we proceeded with using this as our base and customize off of it to meet our needs. Why reinvent the wheel when it's already in production? If you haven't checked out the latest utility network solutions, I highly recommend you do. Again, you have to be water with your technology and software. They're constantly updating it and enhancing everything we touch. Thanks, Bill.
So Mike and Jason, that's a really good project plan. And I know as you were executing it, did you uncover any issues, any obstacles, things that really stood in the way of really following your plan?
And I have 2 really good examples. We didn't encounter these with Oakland County, but the first example is, we were working with a client to map out an old water main that they knew was in the ground. They had a hydrant at the end of the road, that had water service on that wasn't connected to the new main. So we went out there, we set up on a valve with a valve key, connected our transmitter, and we went out there to map it. As we were going along the road, along the water main, it took a sharp 45-degree angle towards the road in the same right-of-way corridor, and then a sharp 45-degree angle up the road. Well, what ended up happening was the old water main was installed decades ago, and the gas company came in and installed their new gas main alongside of it and then crossed over that water main to go back towards the road. When they laid that gas main, though, we believe that the gas main, the tracer wire, was in close proximity or even touching the old water main. And so our signal jumped from our asset to the other asset, and we started mapping that. We tried to locate another valve down the road, but we weren't able to locate one. But that at least gave us an idea as to where it was so that the client could go out there and do some local excavation and isolate and find that water main so we can accurately map it out. The other issue we typically run into is if you have underground power in the same right-of-way or corridor, whether it's in the road right-of-way or going up to a building or a house, underground power zaps all of our signal if you're within 5 to 15 feet of another asset. So if you're hooked up to the gas main, telecom, or water in the same little corridor as the electric, your signal might start off on that, but it's going to jump over to that power because it's going to pull all that signal over. So when that happens, there's unfortunately nothing we can do except try to hook up further down and trace it back, but that doesn't always work out. So with EOS Locate, it's very similar to a traditional utility locator device where you have a transmitter that either sends a signal down the tracer wire or through a direct connect to the conductive conduit, whether it's a valve with a key on it that you hook up to, or spigot on a house, or you can use a clamp as seen on the left here with a bundle of cables around the telecom fiber. The field crews will then record locations being transmitted through that conduit using the receiver in his hand. If you are not aware, now the various companies like Vivax and others are coming out with Bluetooth built in on them to talk to external devices. So EOS sees a prime opportunity and decided to develop a way to connect the locator to their sub-centimeter EOS AeroGold GPS by way of the EOS Tools Pro app. The GPS records your ground elevation, so centimeter, horizontal, and vertical at the user's feet. The locator records the depth at the user's feet. And then EOS Tools Pro subtracts that depth from the ground surface elevation and provides a point location below ground over to field maps. This innovative thinking allows for us, the users, to capture precise centimeter level accuracy of those buried assets live directly into your GIS as a 3D point below ground. Talk about a game changer. Remember when I said that you could have potentially 4 sets of eyes looking at that one asset? Now it's only 1. It's a big time saver, big money saver. This is how we brought our buried assets to life with Oakland County. So utilizing ArcGIS field maps, we developed a custom data capture map in which our field crews can select their asset, again, based on the new utility network framework in which they're set up on, whether it's gas, water, telecom, whatever it might be. And then they start to capture the points along the way. The amount of points you capture is really based upon the asset. If there are adjustments in the height, both vertically or horizontally, the field crews will see that and they should take a point. If it's flat and stretches a long way, you can get away with less points. But if you come to a structure, you just take a standard GPS point using the GPS connected to your backpack of that designated asset within field maps. It's important to note that all layers that are being edited by an external GPS receiver, we must prep that data and the layers that'll be used to collect the data. We have to format the metadata on each feature class to be able to capture key information like number of satellites connected to, or accuracies, which are HDOT, PDOT, VDOT. This is all important when QCing your data on the back end. If something looks wonky, you can go to the metadata and figure out what's going on. We also have to prep the field maps to create a location profile for field maps to talk to our GNSS receiver. This is important so that Field Maps knows how to correlate the location data with the EOS Tools Pro app. Once data capture is completed using Locate, you do have to run a few QC checks to ensure both data integrity and attribution quality. After QC is completed, you will need to run a few basic tools to convert those 3D points to a 3D polyline, where each vertice of that line is each locate point in the field. This will require staff that is familiar with basic GIS principles. And if you want to learn more about the technical information and guidance regarding EOS Locate, please register and make sure to attend the April 29th EOS and Esri Locate workshop.
Wow, that was really, really something else. And that oak tree kind of was a really good story. So tell me a little bit about the results that you had. I mean, did you change the business process? Did you see savings and so forth? Can you detail some of the results?
We were able to map out those 9 asset types found in our AOI in 2 weeks compared to the initial 4 weeks that we had planned for. We now have a full, accurate 3D network of all of those utilities that can be easily exported into AutoCAD or MicroStation to be used for any future projects or designs.
Yeah, now we have much higher confidence in the accuracy of the data we have imported back into our master utility data set. Our staff at Oakland County is now using this in their day-to-day operations.
So back to that oak tree. Here's where the data turned out to be. Again, that dashed yellow line is the original CAD drawing and GIS data. The solid yellow line is our EOS Locate line and points. That pink line would have been what we would have had to collect had we not used Locate. Again, very schematic looking. But when you turn that aerial on now, you see that giant old oak tree right in the middle. So by using Locate, we are able to accurately record the location of that gas main as it been up and around that tree. Here's another location showing a 3D profile looking kind of down on an angle of several assets. Yellow at the top is gas, blue is CCTV, red is electric, orange is fiber. You can see the varying elevations both horizontally and vertically as they were installed. This is very helpful for when trying to design a new conduit that runs into the same building. So you can see exactly where, when you're looking top down, 2D, where horizontally to put it, and then vertically when you're looking cross section, you know where to place that conduit left and right. So given the results and having much higher confidence in the data, Jason, how are you guys at the county looking to utilize the new and improved GIS?
Well, the big one for sure is cost savings. Cost of capture data was dramatically reduced. Cost for Oakland County staff to perform mist digs is going to go way down. Cost for eliminating emergency relocates, utility strikes, and job shutdowns is also going to go down. We have added confidence for Oakland County field staff to trust the data and complete work orders associated to the proper assets. We no longer have to locate old rolled up drawings and marked up plans. Our data is all in one place now, and it's all consistent. This in turn helps my team when we need to provide reports on work. It also helps when looking into the future for capital planning projects. Worker safety will also be increased. We're going to be hands-free now. Crews won't have to walk as much on construction sites to take measurements to find assets. And now they can focus on walking conduits in their exact locations. Being recognized as technologically advanced and forward-thinking is big for us. We want to look at using an augmented reality solution to perform our mist digs in the future. And we want to continue to use high precision GPS to locate all future assets that we add into our GIS. As projects go on, we have to make sure that we're still capturing high quality and accurate data. By having the GNSS metadata that allows for QC checks, we get the confidence in the data shown. We want to make sure that we are keeping up to date with high quality and high confidence in our data moving forward. Long-term with Oakland County, it would be great to continue using precision GNSS receivers and a locate system to continue updating and adding to our networks.
So you mentioned potentially implementing an augmented reality solution for mist digs. If I could speak to that a little bit, using EOS Locate, the goal for the county is to ultimately get their data into an augmented reality solution like a VGIS. With our high confidence in the final data, they will be able to utilize this augmented or mixed reality application on a tablet, phone, or even a Microsoft HoloLens like seen here to visually see their assets underground as if they were really there. So when you look at this image right here, this is what their staff are going to be seeing in the field. The right half of the image is what you see when you walk down the street, but the left half is what they're going to be able to see with their phone or tablet or HoloLens as they're going down. So they can be hands-free, marking off those assets as they go along. Since EOS is compatible with VGIS, we can help make sure that their field staff performing those locates have that same centimeter level accuracy when relocating that asset. So the long-term goal here for the county is to be able to have their field staff utilize this AR system to perform all MISIGs on site. It'll be much safer and much more efficient in the relocating process. So here in Michigan, we have a lot of snow in the winter times. So when we're trying to locate that valve to isolate it to if there's a water main break or some issue going on, we're gonna be able to use this system and see what's below those couple feet of snow, be able to walk right up to that valve in one fell swoop, dig, hit that valve, isolate it, turn it off. Now we've solved our one of our issues. And this is going to be more efficient in the reclamation and helping solve the problem at hand. So with the future roadmap with EOS, one of the things that I like working with them is they're very innovative and coming up with new solutions and ideas to transform and keep evolving their solution. So coming soon, we're going to be increasing their asset attribution, color, symbologies, your feature layers, automating the process of going from points to polylines in the back end. And this is constantly evolving and new things are coming out as we go, which is very exciting. And, relating to that April 29th webinar, which is underground utility mapping with EOS Locate for ArcGIS, the workshop, we're gonna dive deeper into everything related to EOS Locate. Dive into the weeds, get more technical, and explain every step of the way, so you guys can grasp it and deploy it in your community.
I'm looking forward to that workshop, and I think it's a great way to gain understanding about practical solutions. The applications that we've looked at today are built on Esri capabilities for field staff. And this is an overview of how these tools work together to strengthen field operations and to help people work better. They enable field staff to view information that they need, and as we saw today, collect new information quite easily and accurately. Data collection with Esri tools can be configured to suit your needs on a map, as we saw with the new ArcGIS field maps, or using a more form style with Survey 123. And then you'll see quick capture there. That's a simple, what we call a big button app. That's really great for grabbing quick information like you would in a patrol workflow. Down at the bottom, ArcGIS Workforce helps plan and manage work, while dashboards are used to maintain situational awareness of what's happening in the field. And finally, location tracking enables you to see where everyone is in real time. Now, this is very important for those that work alone, like troubleshooters or different types of technicians, for their own safety and help optimize response to emergencies. All of these work together as an integrated system to help field staff. In summary, it's clear that buried assets can be brought to life. It's straightforward to obtain excellent data in normal workflows to capture 3D location, including depth, and store that forever in GIS. I think it's very exciting to think about getting this data kind of for free while doing 811 locates, and then store it and use it for other workflows, including visualizations. Doing things right the first time supports better asset management. It reduces design changes, dig-ins, and speeds emergency response. As we saw, access to accurate data has the effect of increasing everyone's trust in that information and reducing the manual processing from 4 sets of eyes to 1 saves time and money and improves customer service. Mobile tools really are transforming the way that field staff work and making their work safer. We're here to help you with that work, so please make use of our resources. LinkedIn is a great way to see the kind of things that Bill and I and EOS are highlighting on a daily basis. And in addition to the EOS workshop, we have other webinars throughout the year. Please join us in April for the Esri webinar series on field operations for electric and gas utilities. This will be a 2-part series. Part 1 on April 14th will examine tactical awareness of site conditions and hazards and the network. Part 2 on the 21st will look at workflows for collecting and capturing data. And it will take a closer look at ArcGIS field maps. I hope that you can join us. Also watch for our new ebook on field ops coming up in April. Okay, we have a number of questions and we're going to get set up here to address the questions that have been coming in. As we do that, I'd like to say thank you to the audience for your time and attention. And speakers, thank you for your preparation and for sharing with us.
Wonderful. Well, thank you so much, Pat, and all of our speakers, Bill, Mike, Jason. We're going to bring our speakers back on here, as Pat said. Bill had to step out. My name's Sarah. I'm with EOS Positioning Systems, and I will be moderating the Q&A session. We had a lot of good questions come in. I just want to do a little brief housekeeping. If you haven't seen, there are a couple of handouts available in the GoToWebinar that you can download. There's a brochure about the locate solution that was shown, and there's also some resources, additional videos and registration links to the workshop that Mike had mentioned. So we'll get started on these questions. Mike, there's a question that I think you might be able to answer. You showed this workflow in Collector, in ArcGIS field maps. Would you be able to do the same thing in Collector? Have you used it with Collector?
Yeah, absolutely. So we actually started with Collector and then moved over to field maps right away. It can go both ways. Field maps, you get a little bit more functionality with having sketch capabilities. So it's really up to the user, but with ArcGIS field maps coming out and having more functionality, it's recommended to deploy starting off with field maps moving forward right off the bat.
Awesome. And Jason, there was a question about, you had alluded to some of the methods that had been used in the past to try to map these assets with accuracy. Could you discuss in a little more detail some of the methods that you had tried in the past and why they didn't work?
Yeah, most of what we did in the past was, our standard locating. We've done a little bit of work in Collector in the field, but only when the utilities were exposed. I mean, most of the updates that we've had were from, our guys in the field finding where we were inaccurate on our records and basically measuring. Right? We didn't have a lot of GPS points up until this project with OHM.
Okay, great. Mike, you had touched on, I think Bill had asked you a little bit about some of the challenges you faced with deploying this. And someone asked how you're making sure that you're locating your own facilities, for instance, the specific electric pipe that you're looking for, as opposed to another utility asset. You talked about that time when you had accidentally followed the wrong asset. How did you get back on track with yours? And could you talk a bit about identifying the right asset underground?
Yeah, certainly. So, with Oakland County, we knew all the assets on campus was theirs and belonged to them. So anything that we hooked up to, we knew we were operating on our own assets. But with other communities, when you're out in the right of way, whether you're up on your water main or if you're doing work with a gas company, you know which assets you're hooking up to, whether it's electric or telecom or water. So it's you're not really going to confuse the two. Except when you run into that cross issue where we transferred our signal. In that case, we went further down the road. We tried to backtrack it We were unsuccessful in that one case, but it's all about where you set your transmitter up, and depending on how many connections, you might have to replace your transmitter a few times down a big stretch of road or whatnot.
Okay, so there's some skill level involved in that. And Pat, there was a question that came in addressing the level of technical skill that would be needed to build the web map that you would be using to locate these assets in Esri software. Could you speak a little bit to that?
Sure, that's a very insightful question. I would say if you are currently using web maps and apps, if you have collector or field maps running in your organization, then this is a pretty straightforward process. If you look in the Esri marketplace, there is a free template there that you can download provided by EOS, and that will run directly right in collector or field maps to get you started right away. Also, look to online training. There's a lot of training resources available on Esri.com if you need help with those things.
Again, the key thing, like I mentioned in the webinar, is you must process your data layers as you're capturing anything with a GNSS receiver. So you have to add that metadata in order to capture those 3 points that are live post-processed in the field.
Also, if I can add to this, EOS will be hosting a free workshop on April 29 on how to set up your maps and do every single thing from A to Z within the ArcGIS Field Maps app. We've done a couple over the last 2 months on high-accuracy GNSS and also on laser mapping last week. And next month is going to be on the on-the-ground locate, taking you from all the steps from A to Z on how to set up your web maps, your profiles, getting all the metadata fields in there, and how to configure the EOS Locate app also. So you can go on the EOS website and look at and register for that workshop, free workshop.
Yeah, that's good,
Absolutely.
Johnny. Yeah, I like that. Maybe one of us could even post a link for that in the chat right now, because I'm excited for that workshop where you're going to just take everybody through the actual step-by-step process of doing that, and I think it'd be very helpful.
Sarah did post that in the chat for everybody.
Awesome. Yeah, so you can find it in the chat. You can also find it on our homepage. There have been a couple of questions that have come in just asking about that specific process of setting up the web map. So if you register for that workshop, even if you can't attend, you'll get the recording, and we'll walk you through how to set up your web map from scratch in Pro. Jean-Yves or Mike, possibly, this could be a good question for either of you. There was a comment and then a question. GPS signals are weak in alleyways between high-rise buildings. How would the system respond in those situations?
So I'm sorry, Joe, I'm going to hop in. So you'll still be able to accurately measure out in between those high rises where your signal is. You might not be able to get a GPS point because of the mixing of the signals, but you'll be able to at least mark those out. And then you can come back, and if you have structures that you find, you could shoot those with a laser and offset, and then digitize or capture those points along that corridor. You might have to paint that on the ground, your location. Unfortunately, I've yet to run across this issue, but that's how I would approach it at first.
Yeah, that's correct, Mike. I mean, we try to think about these situations where you would be doing locate in impaired environments. And we try to think about combining both the laser and locate, but we cannot ask a locate operator to carry the locator in his hand and then a laser and then do 2 different tasks. I think it's not practical at all. So in this particular scenario, it would have to be 2 passes, one to mark it and the other one come with a receiver with your GNSS receiver using the EOS laser applications for field maps, and then mark those points afterwards. But you would have to manually tie your locate data collection that you do on the side with those points afterwards.
Awesome. We've got a lot of questions in here. Just scrolling to the next one. Jean-Yves, could this locate workflow be done on old sewer pipe that's made from clay, or is tracer wire required for the locates? And there were a couple of people who had asked about that tracer wire requirement.
Yes, I think, Mike, I'll let you answer this one because you've been in the field and then.
Yep. So
you've seen it, done it.
Yeah. So thanks, J.I. Great question. So it's best suited for conductive conduits, so water main, or if you have a tracer wire, that's ideal, like a gas main or telecom, you can send it through. Power, you can capture it as it is. But for old sewer pipes, you do have to get a little creative. I had a client recently take old sanitary sewer mains, take a camera truck and pull a tracer wire behind. And we hooked up to that and we were able to map that out. A lot of complicated bends and drops and whatnot. The other solution is they make a push rod, like a duct hunter push rod, where you can push a rod down your clean out or your lateral or your main, whatever it is. And they have different sizes and thicknesses for the different conduits. But that has a tracer wire built in where you can hook up to that and accurately measure off. And we've been successful with both. Ideally, tracer wire is best though.
Great. So possibly again for Mike or Jean-Yves, in a setting where telecom, electric, water, and gas are all in that close proximity, would this solution be viable, or would that high proximity cause too many problems?
It really depends on, the voltage, and B, the proximity to those said assets. On Oakland County's campus, we had power in the same corridors in some areas, and we were able to get it just fine. In some of the areas, we were able to isolate the power in some of the buildings that weren't being used, and we were able to hook on and map out those utilities. It really is on a case-by-case basis, but again, it depends on the voltage and the close proximity to it. It's hard to give a yes or no to that.
I know also, if I can add to it, every manufacturer of locator will have different settings. And I think that it's extremely important when you're venturing into that you get a proper training from the locate vendor. And also there's specific tuning setup settings that you can do on the locate itself, receiver and transmitter, in order to detect the proper thing and be able to differentiate between one type from another type when you're in the field. So
yeah,
extremely important.
You can set the frequencies. You can raise and lower the frequencies. And with power, I don't know if I mentioned it earlier, with the power, if it's active, you're able to get a good horizontal location for it, but you can't get that vertical, unfortunately. But if that power is turned off and you're like maybe a street light in the parking lot, you want to map the location of that power line going out to the street light, if you can turn that off, you can hook up and measure that, and you will get the depth on that. But if it's live, you can't get the depth, unfortunately.
That's a great point. There is a specific question about the workflow. I know that we've promoted the workshop and the Esri webinars, but for this specific question, Mike, did you locate the target line and then survey the location after you were confident the locate was accurate, or did you do a different setup?
So we found our connection points, and then we set up on it like the oak tree. We set up on where the tracer wires found at the side of the building. We mapped that up and around to the next connection point. From that, we were confident in the horizontal accuracy of that asset and also the depth, because we were getting a really good, strong signal on it. And we can tell we have high confidence in that by just looking at our readings. So there was no need to go back and survey, because in order to go back and survey, you would have hooked a normal locator and literally done the same thing and painted the ground and then surveyed that same location in, which you're doing the same thing twice. So it's not necessary to do that.
Okay.
I think you have flexibility also within the EOS locate settings in order to be able to decide between a fully automated process if the locator person has both hands occupied. So this, with the press of the button on a locator, you can set up a small delay for you to occupy that point if you're carrying the receiver on a range pole or in a backpack antenna, so you position yourself on top of this. And then it starts collect a GPS point, which can went from 1 second to about 60-second averaging. And then after that, you're done. And then it field map submits to the cloud, and then you keep on going by just pressing one button. So it can be as fully automated as this, or it can be fully manual also, or in between the two, depending on what you want in the field. But yes, is first locate to do the locate, and then you collect the point after that once your locate is validated.
Awesome. And Mike, if your buried power cables are stacked vertically, would you be able to detect all of them accurately?
Yes, that's where you would have to have them, if you can isolate them and possibly turn them off. You know, running into the different buildings that we were mapping out, we were able to vertically get our stacks, like I showed that cross-section picture. But if all the power was turned on and you're hooked to it, you're just going to know that there's a power line here. You're not going to be able to get the vertical arrays. But if you were able to isolate and turn those lines off, you can get the accurate horizontal and vertical location of those.
Great. And oh, Johnny?
Yes, if I can add to this on the vertical part, of course, when you do the locate measures the depth below cover. And then what we try to do with EOS locate is also not only pass on all this information as metadata to field maps, to your map as attributes, but also measure the Z value, the absolute Z value of the asset itself. So for this, there are some settings that need to be done where you need to enter your antenna height properly to the ground level, and then from there, we will do the math and then compute the Z value, which is also stored as an attribute, but also stored in the point geometry.
Okay, and Jean-Yves, speaking about the accuracy, is the centimeter accuracy attained when gathering the assets, or with real-time correction, or post-correction?
Real-time correction. We try to push our customers to real-time solutions, and then I think that right now, I think that most of the states, I mean, a lot of countries worldwide, have real-time RTK networks available. So why not make use of them? Because the entire process, when you're dealing with Esri, for example, maps on the cloud, maps on the server, the idea is when you're done in the field, your task is done. You have no more work to do, and that increases productivity. And I think that real time is the way to go, because everything is sync live also in real time. Now there are situations, for example, if you're in the middle of nowhere in a desert, there's no cell phone, there's no base station, and you cannot install your own base station, then there are other solutions available via satellite differential correction, for example, Atlas that we provide, that will provide you with about 5 centimeter accuracy worldwide. So these are other options available for keeping well time in your process.
And we have 7 minutes left and a bunch more questions. So I'm going to combine two here. They're both about stakeout. The first question, I think, for Jean-Yves, will there be a capability to stake out features such as valves and mains?
Not sure if it's related to the locate, but I think that Esri right now has some minimal navigation features within field maps where you can have a point and navigate to that point. When you talk about stakeout, it can be very complex. If you're talking about surveying stakeout, there are many types of stakeout features: slope stakeout, offset stakeout, 2D stakeout, 3D stakeout. It's really, really related to construction. And I don't want to say too much, but I think that there's a few things that you can look for in the future. But I think that Esri also already has some basic features right now on navigating to an existing point and finding that point in the field.
Okay, and to that point, Mike, there was a question. Did you do any utilization or stakeout work to use the data after the locating collection was complete? And if you did, what piece of equipment did you use?
So we just input the data at the end of last year, with construction season starting up here shortly. I'm not sure, that's more of a question for Jason as to if they're going to be doing any digging in that area. But the data just kind of went live into their system recently, so not sure if there's been an opportunity yet, to be honest.
Yeah, I don't think right now we have any plans for that area. So.
So Mike and Jason, you had mentioned augmented reality. Are there technologies or advancements that you're looking forward to coming to maturity in the future that you plan to use this data with?
I mean, the whole AR system, I mean, that's the way of the future, I believe. Going hands-free, you know, but the thing with that, like I mentioned, is you have to have good data coming in to use any of these new technological advancements like an AR system like VGIS. You know, we are confident in the data that we collected, so us portraying that AR data in the field, we're going to have confidence that that is where it is because we used high resolution data as our input. Beyond that, I think that's it for now.
Okay, and for Jean-Yves, have you incorporated any GPR? I'm sorry, probably for Mike. Have you incorporated any GPR or ground penetrating radar data into this, or have you thought about that?
We have not. We didn't have a need for it with what we were doing. We had confidence in the data we were locating with the system. Certainly, you know, if we had a trouble area and this locate system wouldn't be the right application, you can certainly look at GPR. There's pros and cons with that, just like with any system. So.
Okay, so you mentioned having centimeter accuracy, and this person comments that they understand GNSS accuracy is known, but can you be confident about the locator's accuracy?
Yeah, I mean, you can tell the strength of your signal coming in, and you know, your device is telling you that depth and that accuracy. And we actually tested on a few areas where we knew the depth of the gas main, and our numbers were spot on and matched our records that we had.
Awesome, that's great feedback. We are coming up to almost the hour mark, so I just want to note a couple of our presenters have agreed to stay on just a little bit past the hour to answer, or try to answer all the questions that came in. We only have maybe a dozen or so left. If you have to hop off, you will be sent the recording. I think it will come out in a couple of weeks. But if our panelists can stay for maybe 10 minutes, I think we should be able to get through all of these.
It's fine.
Awesome. Then the next question, is this only for the Esri platform? Pat or Jean-Yves?
Yeah, I would say yes. It is only for the Esri platform, collector of field maps. And we do this, you can set in EOS Locate which app you want to use, and then EOS Locate will talk to the proper Esri app in the field. But this is done for Esri collector or field maps running on iOS devices.
Okay. Also for Jean-Yves, can the EOS Tools Pro app differentiate between the different types of utilities when it's using the locate workflow? How do you know you're locating a sewer pipe rather than a water pipe?
It is not up to the app to do this. It's up to the operator and the locator device to do that. And then yes, all the information that comes from the locator, serial number, the frequency, the current readings, everything that the locator provides you to be able to make a judgment of what you're dealing with is transferred and saved in the metadata and also kept for history. And when you want to go back to those, or not only the GNSS metadata, but also the locator metadata is saved. So it's really up to the operator to find out with proper training. And Mike.
Yeah, and I mean, when you set up your maps, you'll have a locator line for gas, water, telecom, all the assets that you're setting out to locate. You'll have those layers built into your field maps or collector. So when you're set up on a water main, you're going to start collecting a water main feature. They'll take your first point, go over to talk to EOS Tools Pro, and then come back. And then every point you click is going to be on that line until you say complete. And then that water main line is done. And then if you move your setup over to a gas main or telecom with a cable clamp or whatever, you'll select that designated asset that you're on, and then you'll start running that until you come to a completion.
I do need to drop. I'm going to sign off. I have a hard stop at 11. So thank you, everybody. Thank you for being our customers, and thank you for being our business partner.
Thank you, Pat.
Thank you so much, Pat. Okay, I know Mike and Jean-Yves, you've said you can stay on. Jason, are you also good to stay on?
I am, yes.
Okay, wonderful. How accurate, I think this is to Mike, how accurate were the locates you did for water and sewer?
Oh, they were super tight. So we actually didn't use the sewer locate on the sewer system. For that, we just GPS the manholes, and there's a straight run of pipe between them. For the water, we used that to trace some of the laterals and also some of the main where we had some issues if there were some bends. But we were very confident in the location results, and it was reading centimeter accuracy the whole time.
That's one thing I wanted to mention. In this application, you probably saw it during the presentation. Jason and Mike used the arrow goal for higher accuracy, so you can expect about 1 to 3 centimeter horizontal, and usually elevation is 1 to 3 times worse the vertical, the horizontal inaccuracy. So basically, anywhere from 0 to 5 centimeters, about 1 to 2 inches vertical is what you're getting with the receiver. So it's extremely important to get, if you want vary the elevation properly, get the part right on the GPS at ground level, and then the rest is your work that you do with the locator that adds on to it.
Okay, great. There is the question about cost, and this, we don't actually have a representative from a locator company on this, but there's a question about the approximate cost of the locating equipment. So Jean-Yves, maybe you could speak to the GNSS hardware side, and Mike, maybe or Jason, about what you paid for the locator.
Sure.
Go ahead, Mike. First.
So with we utilize the ViveX VLOC 3 Pro. And with our accessories, a cable clamp, and a hard case, which I recommend the hard case. It was about $5,500, $6,000 total. Now keep in mind, we have to have the receivers or the locators that have the Bluetooth built in, so they're usually the higher end model with all these different companies that you can potentially look at. Each one of the solutions will do the same thing. The different companies that will work with locate. So my recommendation is to get a couple of them, demo them with the different vendors, and try them out. We like the ViveX the best, which is also the cheapest from our end. And they all have different views and setups to make it look like how you traditionally use your locators that you might have already in-house. And then you do have to have the EOS kit, which I'll let JR talk to.
Right. I can add to this that when we started to locate the EOS locate, the very first receiver that we supported was VVAX. Since then, we've added support for other types of locators. Subsite, for example, is a very good one to look at, and we're just adding support. We just finished adding support for radio detection. So RD 100 and new RD 8200 also coming out, and we're adding support for more manufacturers. And in the case of RD, we had to come up with a special device in order to support this into the iOS workflow. It's called the EOS, which is going to be announced next month, hopefully. And so you're able to communicate. I think that it's up to you really to look at what you want and go through the proper selection of the locate device that you want to use. But we'll support all of them, exact same workflow.
Yeah, and there's a list of supported locators currently on our website. I'll post that to the chat, the specific page link. Speaking of the locators, though, over time, and perhaps Mike or Jason, since you've been working with locators for a while, I think, have they improved the accuracy of the depth location? This customer has locators that are, quote, somewhat accurate.
Yeah, so locators have been around for a while. I've seen so many different versions, very basic to some more robust ones. I can't speak to those accuracies, but the newer ones are, we felt very confident with the results. So the 3 different units that we tested out all had similar depths and results. It just came down to the feel and touch. But we were confident in the accuracies that were given. Like we said, we tested it.
Okay, thank you. And Jean-Yves, can you use EOS offline? This organization has a lot of assets where there is no cell phone signal. If it can be used offline, can you go over the process of how that technology works?
Yes, you can, depend on the type of accuracy that's needed. If you need sub-meter locate, which I don't think you'll do a locate, accurate locate in 3D with that. If you have multiple assets, you know, locator lines, lines running underneath at the same location. So sub-meter might not be a good option, but if you decide to map with sub-meter, then you have WAS, which is a free differential correction signal, which is about 60 centimeter accurate on the horizontal and 1 meter accurate on the vertical. Otherwise, what you can do is, if you don't have cell phone connectivity, as I said earlier, is just go with a temporary or 1 year or 1 month subscription with the Atlas service that provides you with about 4 centimeter accuracy horizontal with the H10 service available. It's very inexpensive, very affordable, and you can do a temporary subscription to do the job in the areas where you have no cell phone connectivity. It doesn't cost you an arm and a leg. I think it's just about $300 or $400 or $300 per month. I'm not sure of the exact price, or about roughly a $1,200 per year subscription if you want.
Yeah, and we use that up in the Upper Peninsula of Michigan with great success, and we were able to get that accuracy where we didn't have great cell service.
That's good.
Yeah, that's a good point. And we showed some images of the GPS antenna, which is on the backpack above the operator's head, and the locator is in the operator's hand. How do you accommodate for that positional difference?
I can answer to that, and Mike, you'll be able to say that. There are various options on mounting the locator. I think it depends on the taste and preferences of everyone. Some of them mount the entire receiver on the locator itself with the antenna. Other people will use a chest pack if they want to use an iPad in the field. So they have the iPad laying on the belly if you want, the locator on one hand, the spray can on the other one. You have a backpack range pole, you got a survey range pole, which is the most accurate of all. But in all circumstances, what you need to do if you want your precise elevation is to measure, once you have your setup, is measure the antenna to the ground. And then what you do is occupy that point after your locate has been captured. So make sure you position your antenna on top of that point, and that you have entered in the settings the proper antenna height with respect to ground. And I think that it does the rest is easy. Mike?
Yeah, great point. So what in the video and pictures you saw Jake wearing the backpack with the range pole. So we measured him staying straight up the height of the antenna, and you add that into your profile in the EOS Tools Pro, which will subtract that distance to the ground surface. So when he's going to take a point, he stands straight up, he puts the locator straight between his feet, basically on the ground, and he takes a point. And we know that there's no shift in his signal, so he's not bending over, which gives you a different elevation and horizontal location. So he stands straight up, puts the head of the receiver on the ground, and then he takes the signal. And then we're confident in that location and that depth of that point. So you do have to be very careful. And he mentioned there's a 3D printed mount for the Vivax that you can put the receiver and everything on top of as well. In that case, we would measure from the tip of the receiver where the antenna is to the ground. As long as you keep that consistent collection posture, you'll be good.
Yes, and again, that's another topic of discussion. If you put the antenna directly on the locator itself, yes, we have GPS, GLONASS, Galileo, and Beidou. We got plenty of satellites to work with. And again, it depends on what your base station or RTK network is broadcasting. If you have a lot of satellites available, your body on top of the antenna is going to obstruct part of the sky. So you have to have the proper, attitude if you want in the field to capture, to see the most of the sky. But if your RTK network is only broadcasting GPS and GLONASS, then it might become an issue if you use the antenna directly on the locate. But again, you have to try it. If you're using your own base station, which is EOS, our Go base station, for example, then you have about 35 satellites to use. But again, you have to be careful for that accuracy, that position of the antenna. Don't forget that we're dealing with 1 centimeter accuracy, and the view of the sky is important when you deal with GNSS.
Yep.
But
Great.
you got setups for all flavors and to please every single person.
And there are a couple more questions related to that elevation factor. Jean-Yves, does the software take into account that the depth reported by the locator is to the center of the utility asset and not the top? Also, the depth report by a locator when using a duct hunter or a tracing wire is to the tracer and not to the pipe.
Yes, what will measure the depth that we use is the depth that's reported by the locate device. So if we have the depth below cover, that's what we will, that's the elevation, the absolute elevation that we will save.
Yeah, so if you're on a conductive conduit like a water main, it's going to capture the top of the water main. It's not going to offset and put an elevation to the bottom because it's not taking into effect the diameter of the pipe. With the tracer wire, if the tracer wire is on the side of the gas main, that's the location that you're going to pull. With the duct hunter, when you're putting it through the pipe, it's probably going to be on the bottom of the pipe. So that's the depth that you're going to get. So knowing that, we know that as long as we know where it is and approximate horizontal, we're going to dig and hit that asset anyway. So we're going to figure out where that conduit is for the most part.
And I can add also, if some offsets are needed in the field, you can always add an attribute field also in your map. So either when you're capturing the data in the field, you enter that offset, then you can do your computations back in the field. So get the, since the offset elevation is also going to be stored in an attribute, is to put that, do your computation afterwards, add fields that you want, and then repopulate the z-value in the point geometry afterwards.
Awesome. And we still have about 125 folks on, and the questions are coming in. So we have maybe a half dozen more.
Let's go.
All right. Thank you, everyone, for staying on. Mike, how are you getting the heights of those street lights or the poles?
Yeah, so for the poles that we need to get, we are using a laser offset to shoot that. Same thing with cameras on top of the buildings, the CCTV cameras. We're taking a location on the ground and we're laser offsetting that point so that we get the location of that asset above ground. In terms of measuring the height, we're not really measuring it. I mean, you could measure it by taking a ground service point at the base, lasering the top, and figure out the height. But for our requirements, we weren't necessarily doing that for this project.
Okay, and I just put a link to laser mapping resources in the chat.
Laser is a very helpful tool, definitely.
Yeah, we just did a training workshop on laser offsets. If you would like a copy of that, you could email marketing@eosgnss.com. I'll put that email address in the chat also. Jean-Yves, related to lasers, locate, another solution or sensor that people have is LiDAR. There's a question, could one collect an EOS receiver to a tablet and a LiDAR sensor where the EOS Aero would feed location to both field maps and the LiDAR sensor?
Yes, definitely. That's what people are doing right now, and there are a couple of options for that. And even for, you mentioned GPR earlier, and that's what people do. They connect directly the receiver to the GPR, and you can do exactly the same thing. So depending on how you're set up, if it's an app that you have that will combine the data from the LiDAR and data from the GNSS, it can be installed on a Windows device with Bluetooth to both of them, and then the app takes care of that. Or if in the case of GPR, for example, what is done is that the GPR has a serial port input from the receiver. So when you get the Aero Go, the serial port, you connect it directly via a cable also to the instrument, and the instrument is able to consume the GNSS data and then push that into the app that the person is using. So yes, you
and
can
with the LiDAR sensors, if you're flying, say, a Matrice M300 with the L1 sensor, the LiDAR sensor, you know, we're using those the Aero Golds for our ground control points and getting confident ground control points. So there's a lot of different ways to use it and connect it to.
Awesome. There's a question, do we offer in-person training for this? I'll just answer that one. Due to COVID, we still cannot do those in-person trainings, but the virtual workshops that we're doing are probably the best way to be trained. So you could subscribe to our newsletter to be alerted to those workshops, and I'll put that link in the chat as well. If you're not already inundated with links. Just a few more questions here. This person says, sorry for the late question, but how are the converted points to polylines being imported into a utility network?
Sure. So we're taking the 3D points because we have an asset ID number per each line. So if we're on line 1, if we take 5 points or 50 points, we know that all those points are to the one line segment. So we're just doing a conversion of points to polyline using those point features because they're all numbered, and that'll convert over to a 3D polyline with each vertex as the elevation and horizontal information with that. And in regards to the training question, we have done some locate training. It depends on the state you are. Not this is unofficial from EOS, but partners like myself, we are able to go outside and do outside training, socially distance, and train clients that are getting this solution. So.
That's a great point. And OHM Advisors is a really wonderful Esri partner. So I recommend checking out their website and getting in touch with them. Mike, has directional bore affected the location data collection?
Yes and no. I mean, with cross boring, say a gas main or whatever. What's nice about the locate is you can actually get the differences in the horizontal and slight variances, left and right as it was bored. So using something like this can actually give you a high confidence in that location because the boring does give you an approximate location of where those assets are. But doing this, we have super high confidence in where these are. In terms of if it goes through another asset, a water main or a sewer main, that's another story. But in terms of being able to collect cross-directional board assets, you are definitely able to do that.
Awesome. So we've come to our last question here, and I think Mike and Jason, you might have opinions on this. So this person says that they have used hyperlinks to historic as-built in some cases from scans or for locations where actual data was imported from schematics drawn on land base. Should all these lines be relocated for accuracy? And Jason, you might have some thoughts on that because you've gone through that. And Mike?
I'd say that's up to you. If you truly want to have these as-built connected, but I mean, historically speaking, it's good to keep that historic information as it is and take new information and use that as your GIS, update those features in your GIS or your CAD, because that's what we're doing with Jason. We have this GIS, but they also have a CAD master utility drawing. So we're updating both places, but we're not updating those historic as-built. I mean, those have a purpose and a reason to be kept. If you want to update those and replace them, you can, but I would keep those old ones and do a second attachment, a second hyperlink with the new data.
Yeah, I would agree with that. That's kind of our approach. So, we do the same thing. We have a lot of hyperlinks, especially within our CAD files. But we have different revisions in different years where we have different data models or drawings historically kept on our network that we can pull them up. But we know now the new information, the new data, the new GIS, or when we open up our CityWorks program and we can see our assets in there, that's the current data that we have. Anything else, if we need to look at something from the past, we'll just go back into those historical records. So, for us, it's important to keep all of it.
And another thing to add to that, so we're doing using locate a lot to find water laterals and curb stop boxes and other shutoff boxes. And so a lot of communities have filing cabinets of the old tap cards and trying to digitize and get away from them. So one of the things that we're doing is locating those lines that are hard to find once and for all, getting an accurate measurement, finding that curb stop box, GPSing it, and then we're taking a picture of that tap card as a record and then basically archiving those as we go through it. But we're using locate to help assist us find where those laterals are once and for all, and we know right where to go back. And so instead of the next time going back there, you're looking at the sketch, trying to measure off 25 feet from the corner of the building, 50 feet from the road. I mean, that's such a time-consuming process. Once we locate it with a locate and high-res GPS, we can accurately go back there and measurement. And then we're just using that tab card as historical reference for materials or sizes on the connection or the service material side.
Awesome. Okay. That was our last question. So I know we've gone 20 minutes over. I really want to thank Esri for hosting this webinar and for allowing us to go over. To our panelists as well, to our attendees as well, thank you for staying with us. I want to thank Oakland County and Jason for coming here to tell his story today, and for OHM advisors and Mike telling us their role in that story, and also for Johnny coming on to talk about the technical specifics. And thanks to everybody who attended. If there's any of the resources that we mentioned today that you can't find, you can always email us or reach out on our webpage. But otherwise, I hope everybody has a great rest of their day, and thank you so much.
Thank you, and feel free to link up with me on LinkedIn if you want, and continue seeing the cool stuff that we're doing.